Hey everyone, today we're talking about how to solve equations that involve parentheses. So now we have 4 steps because parentheses is just the level up for your equations. Now these are probably as complicated as your equations will get. Um, so now your first step is to, once you see that there are parentheses involved in your equations, you actually need to use the distributive property, which we've talked about before, and distribute the outside term to terms inside the parentheses. Then the other steps are just like equations from before. Then you can combine any like terms you see on each side of the equation, use inverse operations to move variables on one side and numbers on the other side, and then solve the equation. So we've added an extra step because of the parentheses. And remember, if you have like terms on the same side, you can add or subtract them like normal, but if they're on different sides, you need to use inverse operations in order to balance the equation. So please make sure that these steps are in your notebook because it can get pretty complicated. So knowing which step to take first will definitely help you out. All right, we'll take a look at this first example, example 6 from the book. Why don't you go ahead and pause the video and see if you can try it on your own first. It's just that extra first step, which is dealing with the parentheses first. Everything else will be the same as before. All right, so again, our first step is to distribute. I see 2 sets of parentheses here, so I'm going to distribute twice. Okay, so let me write this out. So on my left-hand side, I have 9 times x. And then I have an addition, have 9 times 1. Okay, on my right-hand side, I see 2 being multiplied by 3x. And I also see, and there's an addition sign, 2 multiplied by 8. I want to make sure I multiply every term inside by that outside term. So that's why I'm writing it out. I find that when students do the multiplication in their heads, they tend to forget one of the products. So, okay, now let's write down what the products are. 9 times x is 9x. 9 times 1 is a 9. And there was an addition symbol between them, so I'm just going to copy that back down. 2 times 3x is 6x, plus 2 times 8 is 16. So I just finished the first step. I distributed the outside term by multiplying to everybody on the inside. And then my second step is to look at each side and see if there's anything I can combine. Can I combine 9x plus 9? No, I cannot. So I'm just going to leave it as it is. Can I combine 6x and 16? No, I can't. So I'm going to leave it as it is. Now I move on to the next step, which is just moving my terms, my like terms, my variables to one side and my constants on the other. So let me move, I have a 6x here and a 9x over there. I'm going to move my smaller x. This is a positive 6x, so I'm going to subtract 6x both sides. 6x minus 6x cancels. 9x minus 6x is 3x plus 9, which I didn't touch. And then 16 left over on this side. So I have my x's left over on the left-hand side. I'm going to keep that there. I'm going to move my numbers, my constants, to meet each other. It's a minus 9 because it's a plus 9 over here. So I have 3x left over on the left-hand side. 16 minus 9 is 7. So then I have 3 times x, which is multiplying by 3. So the opposite would be dividing by 3. So my answer is 7/3. Or if I want to change it into a mixed number, 3 goes into 7 2 times with a remainder of 1. So that becomes 2 and 1/3. Let me definitely check that because I have a fraction answer. Okay. So I have 9 times x plus 1. So let's do 2 and 1/3 plus 1 equals 2 times 3 times x. 3 times my x. You know what? I'll use 7/3 instead of 2 1/3. Plus 8. Okay. So now I have on the left-hand side 9 times, what is this? 2 1/3 plus 1 is 3 1/3 equals, these two cancel inside. So 3 times 7/3 is really 7 plus 8. 7 plus 8 is 15. So on the right-hand side, I get 2 times 15, which is 30. And then over here, I get 9 times 3 1/3. 9 times 3 1/3. That's really 10 thirds, right? Because 3 times 3 is 9. 9 plus 1 is 10. 10 thirds. So 9 times 10 thirds. Let's see, top and bottom can be reduced by 3. So this is 3 times 10, which is 30. Yep, checks out. Ugh, gross, but it's the answer. Can't do anything about that. All right, let's move on to our next example. Example 6. Go ahead and pause the video, try it on your own first. All right, first step should be to deal with the distribution. So I have 7 times x, 7 times x plus 7 times 2 on the left-hand side. Right-hand side is 2 times 2x plus 2 times 9, because everybody needs to multiply by 2. 7 times x is 7x, 7 times 12 is 14, 2 times 2x is 4x, 2 times 9 is 18. Okay, can I combine anything on the left-hand side? No, I can't, because I have an x and a no x. Can I combine anything on the right-hand side? Nope, I have an x and then I have one that doesn't have an x. So I'm just going to do my normal moving of my x's to join each other, my variables to join each other. 7x is bigger than 4x, so let me move the 4x. Subtract 4x over there, so that 4x minus 4x is done and canceled out. 7x minus 4x is 3x plus 14, just got 18 left over on the other side. Okay, so I'm going to have my x's on the left-hand side. So that means my numbers, my constants, need to be moved over. This is a plus 14, so I need to subtract 14 to cancel that out. I'm left with 3x. 18 minus 14 is 4. And then I have to divide by 3, because this is times 3. So x equals 4 thirds. Another gross answer. Another improper fraction. This is really 1 1/3. So x equals 4 thirds or 1 1/3. Yay, we get to solve that now. Okay, check that. 7 times x plus 2, let's do 1 1/3 plus 2, should equal to 2 times 2 times 4 thirds plus 9. So this is 7 times 3 1/3. And this should equal to 2 times, 2 times 4 thirds is 8 thirds plus 9. Oops, forgot my 2 in the front. So let's see, 7 times 3 1/3. Let's change that to 7 times 10 thirds equals 2 times, 8 thirds is 2 2/3 plus 9. So I'm just changing them back and forth from mixed number to improper fraction. This on the side is 70 thirds, and this over here is 2 times 11 2/3. Whew, lots of fraction math here. 11 2/3 is really 35 thirds. 35 thirds times 2 is really 70 thirds. Yeah, so they both are equal to each other. Yep. So unfortunately, that is our answer. 4 thirds, or 1 1/3. But all we did was just distribute first and then do what we normally do. It's the checking that was pretty gross because it was a fraction. But the work itself wasn't that bad. Once you get a fraction at the end, you can keep it like that as an improper or change it to a mixed number, because as you can tell, there's pros and cons for either format.